Hello everyone. In this session, we will talk about genetic algorithm. So this session will focus on a first introduction of genetic algorithm. First, let's see what it is, genetic algorithm. So GAs were developed in 1970s, quite a long time ago, and now it's being widely used. Nowadays, there are many kinds of GAs, and we call them genetic algorithms, more than one algorithm, following the same idea. The GAs is a method for solving optimization problems, and it has a few characteristics. First of all, it's very easy to implement it and apply to problems. Also, it's capable of solving some quite complex problems that the traditional optimization techniques are not able to. Also, it's popular in today because the computing power is increasing drastically now. So this gives a ground for using GAs because GA may need more calculations, right? In engineering, this could be more simulations. Okay, so this is the general introduction of the genetic algorithms. So many people could have a question. So why genetic algorithm is AI? Right. So genetic algorithm belongs to the evolutionary computation. So evolutionary computation is a field of the computational intelligence. So this is a branch of artificial intelligence. So for computational intelligence, we often to solve problems by copying ideas from the God or nature. So for example, for the artificial neural network that you may have heard of it, so this borrows the ideas from the human brains, right? And for evolutionary algorithm, we borrow from the natural adaptation, right? Or we call it evolution. So that's why we call it evolutionary computation. So to give you an example, let's see the Manchester mouse story. So here I show two pictures. So before the Industrial Revolution, the Manchester mouse looked like this. And after Industrial Revolution, most of the mouse look like this. What is the reason? So to answer this question, right, we can first see before Industrial Revolution, the trunk of the trees are in this color, right, and in this color. So the mouse becomes this color to avoid being observed by birds who will eat them, right? And after the Industrial Revolution, there are more dusts, and the tree trunk becomes this color, right? So then the mouse becomes this color to avoid the birds observe them and eat them. So if we consider the color of the mouse is an objective function to be optimized, and when we optimize to this function, so the goal is to reduce the risk, minimize the risk of being observed by birds. So in this evolution process, the color is being optimized, isn't it? Right. So in this way, we find something, right? In this process, we can extract something, right, that can be used for optimization. Now let's see what can we extract from evolution. So first of all, we must have a population. The population is composed of a number of individuals, right? So the mouse has a population, so it can evolve. The second is quite important, is a selection, based on the rule of the survival of the fittest. So this means the better an individual is, the more possible it will become a parent and survive and go to the next generation, the selection. Not only population and selection, we also need to exchange information between the individuals. So we can see there are crossover and mutation. So when we see crossover, it means the chromosome of a child is a part of it is from his father, a part of it is from his mother, right? It's composed by chromosomes of his parents. So occasionally, some part of the chromosome can be randomly changed. So we call this mutation. So from the mouse story, we extract the population, the selection based on the survival of the fittest, and crossover and mutation to exchange information. So these four elements is what we can use in optimization, right? So now let's change this to an optimization process. How can we do that? First, I would say a solution in the search space. This is what is like an individual in the natural evolution, right? So we call it a solution, an individual, or a point. So these are the same thing as we have said before. Now we will see the evolution process. So the evolution process, the goal is to what? Is to create better solutions. This means that the solution is become more optimized. So how can we do that? So we can say we first have a population of solutions. Then by the selection, we can have the parent set. So we also call it mating pool. This one based on survival of the fittest. So these are the comparatively good ones. Then we will do the crossover and mutation to exchange information among them, and we generate new solutions. At last, the new solutions can replace the old solutions. So these finish one iteration. So we can do it iteration by iteration and gradually improve the quality of solutions, and we finish the optimization. So this is the basic idea of GA. So for details, we will show it in the coming sessions. Okay, thank you very much. Bye-bye.